Hello, I am Dr. Dada Patil and I am going to talk on self-curing or internally cured concrete, a better solution for the sustainable development. So let us begin. Now to start with, on a lighter note, I am showing this sketch where a person to his manager asking that, sir, should we carry out curing as there is no separate payment for it in the contract. So that's very true because we know that curing is very important for the concrete to gain the strength, but that is the most neglected part on the site. Though it is the last part, but since it is not mentioned in the contract because people take it but obvious and they neglect the curing and all the damage happens to the concrete. Now let us quickly see what is meant by curing of concrete. For good quality concrete, placing of an appropriate concrete mix must be followed by curing in a suitable environment during the early stages of concrete hardening. Concrete strength is gained due to the action of cement hydration. The cement hydration is not a momentary action, it's a long term process. The rate of hydration is fast at the beginning, whereas the rate decreases over a period of time. Now, theoretically, the water cement ratio required for a concrete is 0.23 for cement hydration and 0.15 for filling the voids in the gel pores. That means if I add these two, it becomes 0.38. That means total water cement ratio required is 0.38 so that all the cement particles get hydrated as well as the spaces in the gel pores get occupied. However, this is theoretical, but practically speaking, at least a water cement ratio of 0.5 is required for complete hydration in a sealed container so that the desired relative humidity level is achieved inside the body of the concrete. However, in the field, it's totally a different story because though higher water cement ratio is used in the field, sometimes the concrete is open to the atmosphere and therefore there is continuous evaporation of water and therefore the effective hydration doesn't happen. Curing is creation of a favorable environment, that is suitable temperature and sufficient moisture during early period for an uninterrupted hydration. Many times the people think that curing means application of water. It is wrong. Actually, application of water is one of the methods of curing. Curing means creation of the required temperature and sufficient moisture or higher relative humidity inside the body of the concrete so that the concrete attains the desired properties. On site, the story is different. The active curing nearly stops long before the maximum possible hydration. This is because of the lack of knowledge of the laborers, or many times it is the fault on the part of the contractor. Now, this very interesting graph, what it shows is on x-axis there is time and on y-axis there is compressive strength. So here it is 28 days. At 28 days, here it is 100% strength when the concrete is moist cured entire time. That means the concrete is cured for all the time, then they have taken this benchmark as 100%. Now the second curve, there is one curve below, shows that concrete is in air after 7 days. That means the concrete is cured only for 7 days and then it was exposed to the air and then it was tested at 28 days. So the strength has reduced. Approximately it becomes 80%. Again, one graph below it, that is third graph, is nothing but in air after 3 days. That means concrete was cured only for 3 days and then it was left in the air, and then when it was tested at 28 days, the strength still dropped, maybe around 60%. And when the concrete was in the air entire time, that is the last graph, that means no curing was applied, then we can see that at 28 days the strength is only about 50%. So that is the importance of curing period. That means more the time you cure, more the strength it will gain. Now, lack of proper moisture conditions, they virtually slow down the hydration of the cement. Hydration gets badly hampered when relative humidity within the pores falls below 80%, and it practically stops when relative humidity reaches 30%. In conventional curing, there is an external application of water after the concrete hardens, whereas the internal curing or self curing is nothing but a process of preserving moisture in concrete for more effective hydration of cement and reduction of self desiccation. Self desiccation is nothing but the drying of the cement particles from inside. Now, this reduces porosity to a level such that desired strength and durability can be attained, and volume changes in the concrete due to shrinkage are minimized. That is the advantage of internal curing. Concrete which dries out quickly, it undergoes considerable early age drying shrinkage. Lack of proper curing increases permeability as well as absorptivity of concrete. Proper curing reduces porosity of the cement paste. This is because hydration products, that means the various hydration products like ettringite or calcium silicate hydrate or calcium hydroxide, that is CaOH2, all these hydration products, they fill the pores and capillaries either partially or completely, and therefore the porosity of the paste is reduced by proper curing. Curing in arid environment uh, shows that there is more water evaporation. Loss of moisture reduces initial water cement ratio, and therefore there is incomplete cement hydration. The evaporation in the initial stage leads to plastic shrinkage cracking, whereas evaporation in the final stage of setting leads to drying shrinkage cracking. These factors affect strength development rate. At high temperatures, the ordinary concrete loses its strength because there is a formation of cracks between two thermally incompatible ingredients, that is cement paste and aggregates. Because we know that cement paste and aggregates, they have different coefficients of thermal expansion, and therefore they are not compatible with each other, and therefore the crack formation takes place. The mechanism of internal curing or self curing is to hold the preserved water content of concrete structures so that they do not require any additional external water for curing purpose. Now this is very important. 1 meter cube of finished concrete requires about 3 meter cube of water, and most of which goes into curing. So across the world, by research it has been proven that if we want to have 1 meter cube of concrete, then we need 3 meter cube of water. Out of that, the water required for mixing is very less, but majority of the water goes for curing, and this leads to unsustainable development. These four photos clearly show that how there is a colossal wastage of water for the curing on the site. Now on the other hand, there is a scarcity of water in the world, so people, they are striving hard for drinking water. So these four photos clearly depict that how hard it is to get the water across the world for the common people. Now what are the limitations of traditional methods of curing, that is external curing? Providing water for external curing has various limitations, like many times there is a non-availability of good quality of water. There is lack of accessibility of the structure, that is the structures are in remote and therefore you cannot cure it properly. Many times there is very limited water cement ratio used in high performance concrete, that is nowadays we are producing M80, M100 and we use very low water cement ratio, and therefore the concrete needs extra water for curing at the depth. In Indian construction industry, external curing methods are very tedious, that is complicated. They are labor intensive, that means dependent on labor, and they are unsustainable because there is a lot of wastage of water through evaporation as well as runoffs. Now, depth of penetration and effectiveness of water, that is influenced by the quality of concrete. There is a reduction in permeability in the first 2-3 days. That means when the concreting is done and when the external curing water is applied, actually there is a reduction in the permeability of the cover concrete in initial 2 to 3 days. So external water curing is limited in its ability to supply in-depth hydration to the cement. This is because the products of hydration fill in and disconnect the capillary pore network. What happens is that when you start applying the water, external water, then hydration gets accelerated, and the products of hydration, which I already talked few minutes back, they start uh, they start getting filled in the capillary pore network, and those networks get disconnected, and therefore the cover concrete becomes impermeable. Now the impermeability concrete is desirable, but that is after 28 days. But initially the cover concrete should be somewhat porous, so that the externally applied water goes inside the body of the concrete and it cures properly. But it doesn't happen. That is one of the major limitations of external curing. Now this clearly shows the importance of self curing. Now here, uh, at the top it is external curing, whereas at the bottom the diagrams are in connection with internal curing. So I'll explain in short. External curing, what happens is that when you apply external water, the water can penetrate only few inches, maybe 30 to 50 from the top, and the mass below it remains unsaturated, and therefore there is a problem of self desiccation, chemical shrinkage, and many more things. Whereas in internal curing, you are using some uh, self curing agent, which you will see after a few minutes, and therefore there is a distribution of water filled intrusion, and therefore the cured zone is more. So after curing, it is seen that due to internal curing, the it is distributed throughout the mass of the concrete, and therefore it leads to more hydration. Now American Concrete Institute defines internal curing or self curing as supplying water throughout a freshly placed cementitious mixture using reservoirs via pre-wetted lightweight aggregates that readily release water as needed for hydration or to replace moisture lost through evaporation or self desiccation. Now, what are the methods of curing? Water adding method and water retaining method. So water adding method, these are all traditional methods which are unsustainable. Now internal curing or self curing is a part of water retaining method. Again, in that there are two ways. One is, that is way number one, use pre-wetted porous lightweight aggregates like expanded shale, expanded clay, pumice, perlite, etc. These lightweight aggregates, which are pre-wetted for 24 hours and then mixed into concrete as partial replacement of fine aggregate or coarse aggregate, they act as internal source of water. They replace the water consumed by chemical shrinkage during the cement hydration by desorption behavior. That means they leave out the water slowly into the concrete. That is called the desorption behavior, and whatever water consumed by chemical shrinkage, they replace that water. That is the advantage of these pre-wetted, or you can say saturated, lightweight aggregates. Now method number two is using hydrophilic materials in concrete. So the word hydrophilic itself tells that these materials have more affinity for water. For example, SRA, that is shrinkage reducing admixture, these are nothing but self curing agents like propylene glycol or polyvinyl alcohol or paraffin wax or acrylic acid. These materials, they reduce evaporation of water from the surface of the concrete, and they also help in retaining the water. Again, you can use SAP, that is super absorbent polymer. It is a powder. So these hydrophilic materials in concrete, they control the loss of water and they also attract the moisture from the atmosphere. This provides the continuous curing of the concrete. Now let us see what is chemical shrinkage. The major component of Portland cement is tricalcium silicate. We all know that. So whenever the cement hydration takes place, it is nothing but more or less we can say it is a hydration of C3S only, because majority part in the cement is C3S. So the chemical reaction is C3S plus 5.3H is C1.7SH4 plus 1.3 CH. Here I have written shortcuts, that is C actually means CaO, S actually means SiO2, and H actually means H2O. So when I substitute molar volumes in this equation, it is 71.1 for C3S, 95.8 for 5.3H, 107.8 for C1.7SH4, and 43 for 1.3 CH. So when I add this, it becomes 166.9, and when I add this, this becomes 150.8. So these are molar volumes. Now chemical shrinkage is nothing but final volume minus initial volume divided by initial volume. So when I solve this, I get minus 0.0964 ml per ml of cement. That means approximately 9.64%. And you have to concentrate on one thing, that the answer is in minus. So when I convert that into I mean ml per gram of cement, because we know that approximately 50 kg of cement weighs 35 liters, 34 to 35 liters. So when I convert that, it becomes minus 0.0704 ml per gram of cement. So this clearly shows that for each gram of C3S that reacts completely during the cement hydration, we need to supply 0.07 gram of extra curing water so that the saturation is maintained. That is why the chemical shrinkage is the main thing, because of which we have to go for internal curing. Now let us see why internal curing. During cement hydration, the empty pores are created in the mix due to chemical shrinkage. Now, reduction in internal relative humidity within the cement paste occurs. The self-desiccation and lack of availability of moisture within hydrating cement, it causes formation of capillary pores and micro cracks. These micro cracks are the weak planes within the matrix. In practice, the self-curing is used mainly to reduce early age cracking. This is done by maintaining a high relative humidity within the hydrating cement paste and avoiding the self-desiccation, that is, the drying of the cement paste from inside. Internal curing supplies extra curing water throughout the concrete mix. This reduces autogenous shrinkage. So, autogenous shrinkage, in short, I will explain. It is an internal volume change inside the concrete without the moisture transfer from the atmosphere into the concrete. During internal curing, water is drawn from the water reservoirs into the surrounding hydrating cement paste. Now, what are the various ways of providing self-curing? We can use pre-wetted lightweight aggregates. So, this photo shows the various types of lightweight aggregates kept in the jars. So, the efficiency of any type of lightweight aggregate as an internal curing agent primarily depends on amount of absorbed water which that lightweight aggregate can hold, lightweight aggregate particle size and its distribution, and what is the pore structure of that lightweight aggregate. The optimum amount of lightweight aggregate used to attain self-curing is a function of type of lightweight aggregate I am using, the size of lightweight aggregate, whether I am replacing, a fine aggregate by fine lightweight aggregate or coarse aggregates by coarse lightweight aggregates, and degree of moisture preconditioning of lightweight aggregates. Degree of moisture preconditioning means whether I am pre-wetting them for 24 hours, 48 hours or 72 hours under the water before mixing into concrete. Now, this graph clearly shows that how the aggregates are replaced by lightweight aggregate by volume. So, here replacing sand with an equal volume of lightweight aggregate. So, here we can see that up to this it is same. That means cement, water, coarse aggregate, air, it is same. But here the difference is in the conventional concrete, here it is totally yellow, that is fine aggregate, that is sand. Whereas here some part is yellow and some part is this brown in self-curing concrete. That means some part of the fine aggregate is replaced volumetrically by pre-wetted lightweight aggregates. Now, why volumetrically? Obvious, because your fine aggregates have the specific gravity ranging from 2.6 to 2.7 or 2.8, whereas lightweight aggregates may have specific gravity like 1.2 or 1.3 or maybe 1.6. So, when two materials they have different specific gravities, we cannot replace by mass, we have to replace by volume. Now, next is hydrophilic materials. So, these materials form hydrogen bonds with water molecules and decrease the chemical potential of water molecules. So, these materials are actually added by percentage of mass of cement. That means 1%, 2%, 2.5% by mass of cement. They act as shrinkage reducing admixtures as well as self-curing agents. The vapor pressure is reduced and the decrease in the evaporation rate from the surface happens. Now, next is superabsorbent polymers, that is SAP. These are powders. They can absorb and retain extremely large amount of water or liquid relative to its own mass. That means they have peculiarity of absorbing the mass of water more than their own weight. The water absorbing polymers, which are classified as hydrogels, they absorb aqueous solutions through hydrogen bonding with water molecules. Now, let us see the last part, that is scope for internally cured concrete or self-curing concrete in India. After agricultural sector, construction industry sector is the second largest contributor to Indian economy. The construction sector needs to be taken on priority basis in terms of providing the world class infrastructure as well as delivering time bound projects. The success of Indian construction sector, it largely depends upon the availability of raw materials, skilled manpower, construction equipment, and state of the art technologies. Availability of required quality and quantity of water is really a big issue on many construction sites. The unskilled workers, they don't realize the importance of adequate curing. They are producing a low quality concrete. Sometimes, on the contrary, they waste huge amount of water for the curing purpose. That is also not correct, and therefore there is a need of producing the concrete with judicious and optimum use of constituent materials, including water, in order to cope up with the field requirement of workability, strength, and durability. India has complex physical diversity in the form of temperatures and humidities. We know that from Kashmir to Kanyakumari and even from east to west, we have different temperatures and different relative humidities, and these factors are important for concrete performance in its life cycle. Therefore, internal curing or self curing can be practiced on a large scale that would really lead to a sustainable development in our country. So, this I want to end with this photo that at one end we are making colossal wastage of water for external curing, though there are many limitations of external curing, and on the other hand, the people across the world and especially India, they have scarcity of drinking water, leading to unsustainable development. Thank you very much.